Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on December 30th, 2025, about 4 days ago. It presents a new metaheuristic framework called TESO that leverages short-term and elite memory to navigate noisy search landscapes, achieving a superior mean objective score of 2.53 against a baseline of 4.11. The paper is titled TESO Taboo Enhanced Simulation Optimization for Noisy Black Box Problems. And as we'll see in the results, the ablation studies reveal exactly why combining these memory strategies is so effective for robustness. For those interested in the implementation, the authors have shared their code on GitHub. Figure 1 maps out the workflow of the TESO algorithm. The process hinges on this central decision logic, which determines whether to diversify by picking a random point or intensify by perturbing a high-performing elite solution. Next, the flow moves to the taboo check, where the algorithm filters out recently visited solutions unless they satisfy an aspiration criterion. If passed, the candidate undergoes a rigorous evaluation with multiple replications, updating the system's memory before the next iteration begins. Well, Figure 2 results from that process, plotting the best objective value found over 300 iterations. The red line at the bottom represents the full TESO framework, which dives quickly to meet the dashed gray line, marking the true optimum. Contrast this with the blue line at the top for pure random sampling, which barely improves. The chart also isolates specific components, with the intermediate orange and green lines showing how performance worsens without elite memory or the taboo list. This confirms both mechanisms are needed to hit that optimal cost of about 2.5. So Table 1 puts precise numbers on those visual trends. It compares the benchmarks and ablated versions against final objective values and runtimes. The top row shows that pure random sampling is the fastest, taking about 53 seconds, but it lands on a poor mean objective of 4.11. By comparison, the bottom row reveals the complete TESO algorithm achieves the best score of 2.53. It also maintains the lowest standard deviation of 0.07, which confirms that the extra computation time yields significant gains in stability. Wrapping up, the main takeaway is that navigating noisy black box landscapes requires a deliberate balance between memory-based exploration and exploitation. The results prove that combining taboo restrictions with elite guidance prevents the search from cycling or stagnating, ensuring a reliable convergence where standard methods fail. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.